If k is greater than 0, solve the equation k plus 1 all in bracket factorial divided by k minus 1 all in bracket factorial is equal to 30, right? So let's find k plus 1 factorial first. So to find k plus 1 factorial, k plus 1 factorial will be equal to k plus 1 times k. You subtract 1 from k plus 1, which will give you k, right? Times k minus 1 all factorial, right? That's k plus 1 factorial. By substitution, we have k plus 1 factorial to be equal to k plus 1 times k minus 1 factorial divided by k minus 1 factorial, right? Divided by k minus 1 factorial to be equal to 30, right? So now k minus 1 factorial will cancel k minus 1 factorial here. K minus 1 factorial will cancel k minus 1 factorial, leaving k plus 1 all in brackets times k equal to 30, equal to 30. Now let's expand the brackets. By expanding, k will multiply by k here, and the same k will multiply by 1 here. So k times k will give you k squared. K times k will give you k squared, right? And then k times 1 will give you k to be equal to 30, right? So let's group like terms. 30 across the equal sign. So let's bring the 30 here. And by so doing, we have k squared plus k minus 30 to be equal to 0. And this becomes a quadratic equation. They said we should solve the equation. So the question demands us to find k, right? But this is a quadratic equation because the power here is 2. If we check the power here, the exponent here is 2. So this becomes a quadratic equation. So how do you solve this quadratic equation to find the value of k?
Please subscribe to the Wood Maths class at TikTok, Facebook, Instagram, YouTube for more videos like this. Thank you.
Now, how do we solve this quadratic equation? We have the quadratic equation k squared plus k minus 30 is equal to 0, right? So now, with the quadratic equation, the first step is to take the constant, and the constant here, the constant here is 30. The constant here is 30. So you take the constant and you multiply by the coefficient of k squared, and then here, if you check the coefficient of k squared, here, the coefficient of k squared is 1. Since it's just k squared, there's no number attached to the k squared. So the coefficient of k squared is 1. So you take 30 times 1. That will give you 30. Then you find the factors of 30, both positive and negative, such that when you add them, you will get k, which is in the middle here. You find the positive and negative factors of 30, such that when you add any of the two factors, you get k. You get k here. When you add them, you get 1 here. So let's look at the factors. So factors of 30, we have 30 times 1. 1 and 30 are factors. And then we have 15 times 2. 15 and 2 factors. And then we have 6 times 5. So 6 and 5 So 1, 2, 5, 6, 15, and 30 are all factors of 30. So you find out the pairs such that when you add them, it will give you 1. You realize this will satisfy the equation. This will satisfy that condition. 6 and then 5. 6 minus 5 will give you 1. So that satisfies the condition. So let's substitute it inside the equation. Then we'll now have, let me clean this. We will now have k squared plus the 6, one of the factors, the pair of factors, 6 and 5. So you consider 6 first, 6k. Instead of k, you put 6k and then the minus 5. So that's minus 5k minus 30 is equal to 0. Let me clean this too as well. It's equal to 0. Yes, it's equal to 0. This is 5. Okay. So we now have k squared plus 6k minus 5k minus 30 to be equal to 0, right? So now let's factorize k outside. Then we have k here. We have k here, k squared plus 6k. So you can factorize k outside. Then you put k here. That k outside times the k inside will give you the k squared. Plus, we have 6 here. K times the 6 will give you the 6k. Then we have negative. Now we have minus 5k and then minus 30. We can factorize minus 5 outside. So we have minus 5 here. Then we have k plus 6. The bracket is equal to 0. Now, we now have, we just take the one of the brackets. That will give you k plus 6. Then we take the numbers or constant that are outside. Then we have k minus 5 is equal to 0. And d minus 5 and then k plus 6. So let's find k from that. So since we have k minus 5 and then k plus 5 is equal to 0, let's take each of the brackets and equate them to 0. So the first one, which is k minus 5, is equal to 0. Let's find k. So you just bring the negative 5 across the equal sign and it becomes positive. So we have k to be equal to 5. And the second one, we have k plus 6 is equal to 0. So since it's positive 6, when you bring it across the equal sign, it becomes negative 6. So we now have k to be equal to minus 6. So k is equal to either 5 or negative 6. Either 5 or negative 6. So when you substitute either 5 or negative 6 inside the quadratic equation, it should satisfy, right? It should satisfy the quadratic equation. But from the equation, let's make reference to the question again. It is greater than 0. So meaning k should be positive. It's a condition that k should be positive. So the final answer will be k is equal to 5 and not k is equal to negative 6. The final answer is k is equal to 5 because the question states that k is greater than 0, which is positive.